So, getting into today's lesson, we're going to talk about the inverse of power functions. Power functions being x squared, which that's what we're going to deal with the most, and x cubed, so quadratic and cubic. It says the inverse, talking about the inverse of a function. A function is a set of all ordered pairs x and y for where each x value there is a y value. So hopefully everybody knows that. Just identifying if it is a function. The inverse of a function reverses the pairings of a relationship, switches x and y. We've talked about this earlier in the year. So if you had a table of x's and y's, to get the inverse, you would just switch your x's become your y's become your x's, and that's your new values for the inverse. It says the graph of the inverse is a reflection across the line y equals x. Don't put this line on this graph, but that's just here in a minute. Whenever we graph the inverse of that cubic, it will reflect across that line right there. Okay, so that's kind of remember how that relationship is. So question number 1, how do you tell if an equation or if a graph is a function? Somebody tell me. There's two big ways. Do what? Okay. And I'm gonna write it this way. For each x value, for each x there is only one y. What's the other way? More specifically, how would you do it if you had a graph? If you had a graph and you had to determine if it was a function or not, how would you do that? Vertical line test. So on this next one, how do you tell if a function is a one-to-one? So this is something that's a little bit different than just identifying if it's a function. And the rules are kind of similar. Okay, for example, the first rule of this, I can copy that right there. For each x, there is only one y. But after that, for each y, there is only one x. Okay, so if you had the points 2, 8, and 3, 8 within a whatever function it may be, or whatever equation it may be, that would be a function. Okay, the points 2, 8, and 3, 8, that would not be a one-to-one because the y value 8 has two different x values, 2 and 3. So that would be considered a function, but it would not be considered a one-to-one function. If it's not a one-to-one, then the inverse is not a function. Okay, that's kind of what that tells you. How you can tell also if you're looking at the graph, you would look to see if it passes the horizontal line test. And that's the exact same idea as vertical, just with a horizontal line. So just so you know, on talking about number 1, this is telling you about the original. Number 2, this information is telling you about the inverse. Which I think I skipped a paragraph or a sentence up there that I'll need to go back up and talk about. Yes. So let's go back, look up at the second sentence up here, or the second part that I didn't talk about. It says, if the inverse of a function is a function, then it's called the inverse function, and is written f, looks like f to the power of -1 of x. Okay, so what this is really saying, this is just kind of the notation rules, so how you would write it. If the inverse is a function, then you would use this. If it's not a function, you would just say y equals. Okay? So the inverse of a one-to-one function will be a function, which is kind of what I was telling you as we were filling out 1 and 2. And it says it is invertible. I don't really like that notation, or that verbiage, so don't worry about that. Okay? So that's all that's saying. If it's a function, you use that. If it's not a function, you don't use it. That's all that part is saying, but it is important that you know that. So let's go to these right here. So first, looking at the cubic, and the inverse of this is going to be a cube root. So it says, is the cubic function, which is there to the right, is that a one-to-one function? Yes or no? Why? Passes the horizontal line test. Then it asks us to write the inverse, so it says to switch x and y and solve for y, which that is the process and how we're going to write the inverse if you have forgotten. So if this is my original equation, y equals x cubed, I'm going to switch x and y, and then how do I get the cubed off of there? Cube root. And then because the original was a one-to-one, I would need to write it like that. So it says, next it says to graph the inverse on this coordinate grid over here. So this should be pretty easy, because if the original has the point 2, 8, that means the inverse is going to have what point? What? 8, 2. You just take the x value and the y value and you switch it. Now those next 3 points there in the middle, and I'm kind of doing this right to left, which is a little backwards, but if I'm doing this from right to left, these 3 are going to stay the same because both the x value and y value are the same. And then if I have the point -2, -8, the inverse is going to have what point? -8, -2. And so this would roughly be that graph, like I had mentioned previously. It reflects across that y equals x line. So we've kind of beaten around this answer already some. Is the inverse, so what we just graphed, is it a function? Yes. Somebody give me a reason why. What's up? Somebody tell me why the inverse is a function. Okay, no repeating x's. That could be a correct answer. Someone tell me another one. Passes the vertical line test. Okay, so on that, you would want to say, and I'm going to say that same thing in a different way. Okay, I would say that the original is a 1-to-1. Now, if you were to say that the no y values repeated, you would want to say no y values on the original repeated. But saying that it was a 1-to-1 is the same. So if you've forgotten also how to do the vertical line test, if I take any vertical line and I put it through that graph and it only crosses it once, so just looking at the red one, then it is a function. So if I gave you a graph that looked like this, let's say it was just a circle, which we don't see in here because all we really deal with in here is are functions. But if I gave you that graph and asked you if it was a function or not, you put a vertical line through it, it crosses it twice, then that is not a function. But we rarely see that in here. We're actually going to kind of see it here in a minute though. But we rarely see it in here because we mostly just deal with functions in your favorite math class ever. So going down to number 2. Now looking at the quadratic, which the inverse of a quadratic is going to be a square root. So on 7, it says, is the quadratic function a 1-to-1? No. Why not? Do what? What values specifically?
Y.
There's repeating y values, or you could say that it failed the what?
Horizontal line.
Fails the horizontal line test. So now it says to write the inverse of it. So it's going to be the exact same process. Here's my equation. I will switch x and y. And then how do I get that squared off of y? Square root it. So how do I need to write the inverse of this one? The top one or the bottom one?
Top,
Why the top?
because it's not a 1-to-1.
Because it's not a function.
Yes.
Okay? That's what the original not being a 1-to-1 tells us, that it's not a function. So if I was to graph this, and technically, and also just so if you see it written like this, you don't freak out, we're actually going to graph the true square root. Okay, because the square root of 4 is what? 2. The square root of 4 is also what? Do what, Rachel? -2. All right, I'll kind of expand on that here in just a second after we graph it. So if I graph this the same way I graph the cube root up above, if I have the point 2, 4, the inverse has what point? 4, 2. All right, then I've got 1, 1 and 0, 0, which again those are going to stay the same. But then if I have the point -1, 1, what point is the inverse going to have?
-1.
1, -1. And then if I have the point -2, 4, my inverse is going to have what? 4, -2. Again, it is reflecting across that line. So if you're looking at this, again, the square root of 4 is 2, but it's also -2. For the same reason that 2 squared is 4, -2 squared is also 4. Okay? So make sure you're aware of that. Now, to make this a function, we're going to, on the next page, we're going to talk about something called a domain restriction so that we can have a square root function and are able to use that for data if need be. So go to the next page. And this is where it's going to talk about that domain restriction. So it says the function f of x, x squared, is not a one-to-one. Y'all have already told me that. However, if we restrict this function's domain to when the x values are positive, then we have a function that is a one-to-one. So what it's saying is we can take the original quadratic and essentially we're just going to focus on this part of the quadratic. As a result, f of x equals x squared has an inverse function for the domain when the x values are positive or when x is greater than 0. The square root function only utilizes the positive square root. F of x equals the square root of x. So, to get the inverse square root, to make it a function, we just use this data. And so, really, from here on out, for the most part, all we're going to be focusing on is this part of the graph. Next class, whenever we talk about transformations, we're going to take that and we're going to move it, whatever, up 3, left 2, and it's going to be there, or left 3, down 4, or wherever it is. Okay? And whenever we talk about this, in my mind, this is probably the easiest function to graph, probably even more so than a linear line. All right, graphing these are not difficult at all. So you got this little table down here. This talks about, this has your parent square root function, and then your parent cube root function, which if you notice, this looks somewhat similar to this, but it does go up at a little bit higher rate than your cube root. Okay, so a lot of that is just kind of conceptual stuff of where the square root function comes from, why it just looks like it's the top part of a parabola, because essentially it is, just turning it sideways. Okay, so looking at this, all we're going to do here is it says that each function, it's already a one-to-one, so we know the inverse is going to be a function that tells us how we should write the answer. We're not going to do the domain and range. Next class we're going to talk about graphing, and we'll look at that next class. So, going through here, we're just going to go through all these, and we're going to write the inverse. So if this is my equation, the first thing I'm going to do is switch x and y. And then if I want to solve for y, what's the first thing I need to do? I'm going to subtract the 4. So I've got x minus 4 equals y squared. And then do what? Square root it. So, I do have a question. If I square root it, is that my answer? Or is that my answer? Or does it matter? The first one, the second one, or does it matter? Okay, there's a lot of hesitation. So, what I want you to do is I want you to put that one into y1. I want you to put the second one into y2. You may get lucky, it may already be in there. But whenever you put that first one in there, you have to arrow out of the square root before you put the minus 4. Okay, so they are very different. So now going back to this, back to the problem, which one is my answer to this problem though? The second one. Alright, now look at this step right here. The step where I went from that to square rooting it. If I square root the right side to get rid of this, I have got to square root the whole side, which has everything underneath that. So this first one would not be my answer, and this second one would be. Going to number 2. So I'm going to go ahead and switch x and y just on this first step. Now on this one, what am I going to do first? No. I don't want to talk about that here in a second. What do I need to do first? Square root. So I've got the square root of x equals y plus 3. Sorry, y minus 3. And then what would I need to do? Add the 3. So is the plus 3, is that going to be inside the radical or outside the radical? This one is going to be outside the radical. And there is a huge difference. You just saw the difference on the graph. Those two situations are probably the two situations that give most people fits. So kind of look up here and listen. And all it is it just matters whenever you do the square root, whenever you get rid of the squared and you square root both sides. Because again, you're going to square root the whole side. So whenever I did the square root, I had x minus 4 over here already. So all of that is underneath the radical. Whenever I did the square root on this one, all that was over here was x. So everything I do after that step has to be outside the radical. Okay? Going to the last one on this page. What's the first thing I need to do other than switch x and y? Subtract 2. And then do what? Square it. So I've got the inverse of f of x. Now what do I need to square exactly? Or how do I write that? Parentheses x minus 2. Because I have to square the whole thing. So I have to group that whole side together. And then square it. Now, looking at this real quick, on number 1 and number 2, I started off with a quadratic, and I ended up with a square root. On 3, I started off with a square root, and I ended up with a quadratic. Always make sure that you know what the inverse of those are. Don't have a quadratic, don't be given a quadratic, and then tell me that the inverse is some other quadratic. That doesn't make sense. All right, they're in quadratic and square root are opposites of each other. So make sure that you keep that in mind. Going to the next page, this gets into a little bit of cubic and a couple other different situations. Now I'm going to do the 6 up there on the board with you. And then I'm going to have you kind of just work on the rest together. So if you want, go ahead and kind of start working in front of me though, and I'm going to be putting these answers up there. And if you have a question on one, please make sure that you ask. I'll be more than happy to explain, go through them, especially number 2 down below. There's the answers for the first two up there. And everybody look up there real quick. Whenever you write these answers, guys, be clear as to what is inside and outside the radical. Okay, don't, if it's one way or the other, I can tell you right now, if you try to play this game right here, all right, where you kind of put it over so that I grade your quiz or your test and I hand it back and you're like, oh, well, that's what I meant. Okay, you play that game, I'm not interested in that game. It's going to be wrong no matter what the answer is. Okay, it needs to be clear as to what is inside or outside that radical. If you want to be very careful with it and make it very clear, you can put parentheses around what you are intending to be underneath the radical. There's number 3 right there. There's the answer to number 1. And we will probably need to talk about this next one. All right, everybody look up here on this next step. So what's the next thing I need to do here? And I'm finding the inverse of this one. Flip x and y added 4, square rooted, subtract 3. So is my answer going to be the square root of x plus 1 or the square root of x plus 4 minus 3? Okay, Alvin thinks x plus 4 minus 3 is everything. It's going to be the square root of x plus 1.
Can you not just, when you already squared rooted it, can you not just do plus 3 minus 4 and then add plus 1 on both sides? And
No.
Just get it 1.
Yes, ma'am.
So it would be x plus 4 later. Yeah, x plus 4 and then we would do minus 3 because it's not under the square root. Right?
Correct. So you'd end up with this right here, sorry, plus 4, minus 3, and you cannot combine those. Do not do 4 minus 3. This is inside, this is outside. All right, and some people get stuck as far as the process of getting stuff over, and Dalton said something earlier that I wanted to touch on. Whenever you're finding the inverse or you're solving for y, if you remember earlier in the year we talked about this right here. Okay, SADMEP. It's PIMDOS backwards. So whenever you do that, you're always going to look to add, subtract and add first. Those two kind of go together. So on this step, I could add the 4 over to the other side. Next, I look to multiply and divide. There would need to be something in front of these parentheses here that I would need to divide by at this point. There's not, so I go to the next one. Okay, I've got an exponent. Yeah, I need to deal with the exponent, which means that I would square root it. And then if you get to the p, and then if that variable, if that y is not by itself, you start back over inside the parentheses. So I started back over, I subtracted the 3, there was nothing in front of the y for me to divide, so I'm done. Okay, so you kind of follow that, you work outside the parentheses, or outside the radical, however you want to see that, and then whenever you get to the p, then you work inside the parentheses or inside the radical, just depending on what you're given. Okay. Every step you take should move something from one side of the equation to the other. Okay, and Dalton, you had said something earlier, I think you said that maybe you multiply two things on one side, on one of the steps, on one of the problems we saw earlier. Okay, but if I do something and I multiply those things together, like let's say on number 5 up here, if I did y plus 1 times y plus 1 times y plus 1, or even if I just expanded that exponent, I didn't move anything. I just rewrote one side. Every step you do, every step we've done has moved something to the other side of the equation. Okay? And then looking at this last one should be pretty simple. Just square root of x plus 3.